Hey guys, welcome back. I was dealing with the reactions of the metals of group number one with different acids. We have discussed the reactions of group number one with hydrochloric acid, with sulfuric acid, and with nitric acid. I am now going to discuss a few more reactions of other acids. Guys, there is another acid, and that is called as CH3COOH. This is the formula for this is the formula for ethanoic acid. In the next topic, when I will teach you about acid, bases, and salts, inshallah, then you people will have a better idea that what is the difference between organic acid and inorganic acid. It is one of the organic acid. Okay, organic acid, and that is also called as the carboxylic acid, carboxylic acid or carboxylic acid. All right, now if we are going to react with these acids, any metal of group number one should know this thing at this stage, that this is the hydrogen which is the replaceable hydrogen. Okay, so this is CH3 COOH is reacting with lithium. CH3 COOH is reacting with sodium. CH3 COOH is reacting with potassium. Here the product will be CH3 COOLI. Along with that, H2 gas will be formed. So this is the only hydrogen which I have mentioned above is the replaceable hydrogen. This COOH is called as carboxylic group. So the only replaceable hydrogen is the hydrogen of carboxylic group or the carboxylic group. Okay. Details of carboxylic group will be taught to you in the chapter of acid, bases, and salts, and further more details will be taught to you in the chapter of organic chemistry, inshallah. So here it is not the balanced chemical equation. So I'm going to write two over there, two over here, and two over here, as it is just the one hydrogen which is replaceable. So in the same way, rest of these all are reacting. The compound formed here is called as lithium ethanoate. Lithium ethanoate. In the same way, the next will be sodium ethanoate and the last will be potassium ethanoate. So the product here, it will be CH3COONA along with H2. The product in the last will be CH3COOK, potassium ethanoate along with H2. Can we write it like CH3CO2Na and CH3CO2K? Yes, we can write it like that as well, but it is better to write it like CH3COO. I mean to say, don't merge these two O's. It will help you to understand the bonding in this compound. So it is better to write them separately. Okay. Now we have to write the balanced chemical equation. So I'm just placing twos with all of them to tell you that all of them are reacting in the same pattern. Okay. So this is the reaction with ethanoic acid. And now I'm going to show you the further details about group number one. So we have discussed the reactions of group number one basically with metal oxides, metal hydroxide formations, with steam and water and different salt formation in case of acids. In all cases, hydrogen gas was the common product which we were preparing, and all these. Right now we are going to discuss the reactivity trend in group number one. Okay, reactivity trend in group number one. Okay, what is the reactivity trend in group number one? Reactivity increases down the group. Reactivity increases down the group. Okay, why reactivity is increasing down the group? This is the actual point. So what is the trend here? It is the lithium which is the least reactive, and let me inform you that it is the francium which is the most reactive. Why it is? Okay, guys, the point is this, that in case of metals, these all group number one, we may say group number one, all are metals, all metals. Okay, and in case of metals, the reactivity is basically based upon the ability to lose an electron. Okay, higher is the ability to lose an electron, higher will be the reactivity. Okay, lower will be the ability to lose an electron, lower will be the reactivity. Okay, Let's see. For example, this is lithium, and lithium has an atomic number of 3 and mass number of 7. So if 3 is the atomic number, what will be the electronic configuration? 2 comma 1. It means the 2 electrons are in the first shell, first electronic shell, and 1 electron is in the second electronic shell. Let's draw this. Okay, so this is the first shell and this is the second shell. All right, now just consider, for example, we are saying that this is potassium. Okay, potassium has an atomic number of 19, whereas the mass number is 39. So 19 is equal to 2881. Okay, so it has 4 electronic shells. Okay, it has also 1 electron in the outermost shell, as all the elements of group number 1 will have 1 electron in their outermost shell. All right, so this is the first shell here, and now this is the second shell here, and the third shell will be on the next